Here's my demonstration for SCADA Lab04. I'll go through the registers first, quickly. So this first one is the tank level, so this is just the water level in our storage tank. It's an unsigned 16-bit word, can be any value from 0 to somewhere in the neighborhood of 65,000. Next, these two booleans represent power supplied to the pumps and valves. So if they're false like they are now, water pump is off, the valves are closed. If we change it to true, valves are open, pumps are on. The flow level just represents a flow meter we have in the design. It's the same as tank level, same numerical format as the tank level. And these two registers are the upper and lower bounds for the tank. So if the tank level is above the upper bound, turn everything off. If it's below the lower bound, turn everything on, fill the tank back up. That brings us to the instrumentation panel, which is built on top of this diagram. I think the most obvious feature is the storage tank visualization, which we can change just by typing a number into this register over here. You can also change those upper and lower bounds I was talking about. Oops. And this part of the system is represented by these three functions. So this is the same sort of water level sensor described in Lab 3, and this level recorder I'm implying is connected to this historical data viewer. This then connects to what I'm calling a flow controller. That's not exactly what it is. All of its outputs are binary outputs. It's just switching valves on and off, or switching pumps on and off. But it technically does control the flow, so I called it a flow controller. Also connected to that is this flow meter, this flow transmitter. And I'm not using that in the actual control of the tank level. I'm using it to verify functionality in the system. So right now you can see there's a flow. The flow is not 0, it's whatever, 60% of its maximum. And under normal conditions, that's fine, the tank is filling up. But if we want the pumps turned off, then we would expect that flow to drop to 0. I don't have anything like that simulated, so it's not going to drop to 0. So if I turn the pumps off, but there's still a flow, that's a big problem. So I have this red indicator and this alarm set up when that happens. And if we change the flow back to 0, then there's no problem, we're back to normal. Anyway, that's what the flow meter is doing. And you can see the historical data ticking away. Okay, that's about it for the instrumentation. I'll take you over to the ladder logic. So a lot happens in this program, so I'll explain it before I run it. On the first cycle, we move these two values into these two registers, and this one represents the upper bound, this one the lower bound. This is negative because this program uses signed words, whereas WinTR uses unsigned words, as you can see. So a number greater than 32,000-ish is represented by a negative number instead of a positive. So this second rung, it's polled every 100 milliseconds, and it does two comparison operations between the upper bound and the actual value, which I'm calling D0, and the lower bound and the actual value. So I'll take you through one case because they're identical. So if D0, the water level, is above our specified maximum, then Y1 is set, and Y1 resets 3 and 4. Now Y3 and Y4 represent our pumps and valves. So those are set to 0, which means they're turned off, which is simple and fine, but there's a possible situation with this system where if the water level is near its maximum or above its maximum and someone is also using the water, you could have a situation where the water level is fluctuating between the upper bound and just below it. And that's bad for the equipment, and it's just not very good control to have things switching on and off constantly like that. So I've implemented a delay between how often the system can make decisions about the valves. So when either Y1 or Y2 is active on the rising edge, we set Y5, which you can see locks out the comparators. So we can't make any comparisons, we can't make any changes to the system. And Y5 also triggers a timer, which when it reaches its value, I set it to 100, which is not very long. I would think around 5 minutes would be reasonable. But anyway, once that timer is elapsed, it resets Y5 so the system can make changes again, and it resets itself to prepare for the next cycle. So it's a fairly simple program, but effective, I think. And let's just upload it and run it and take a look. There we go. You can see since the initial water level is 0, these are set because it's less than the minimum. I was not fast enough to catch that timer to talk about it. But anyway, we can see on the first cycle, these two registers get loaded. And we're doing a comparison every 100 milliseconds, as you can see. This comparison is returning true, which is setting these two values. Anyway, just like I explained it. So let's stop and restart. Now you can see, because we made a change, the timer is going up, and we're locked out of the comparators. Once this reaches 100, right now, the comparators are back online, and the system is reset and ready to go again. So the timer doesn't force a change to be made, it just locks out the possibility of a change for some set time.